Hello students and welcome to Math Weekly number 25. In this Math Weekly, our focus skill will be on two-way tables, and you can see an example of a two-way table here in the center of the screen. Let's begin this lesson by what a two-way table is. A two-way table organizes two sets of categorical data. They can sometimes be numeric like years or etc. using rows and columns. You can see that this two-way table is showing us the response of people to whether they like or do not like skateboards, as well as their response to whether they like or do not like snowmobiles. Our goals for this lesson are to be able to read a two-way table, to finish a partially completed two-way table, and to calculate percentages based on a two-way table. Let's begin with our first goal. Our first goal is to be able to read a two-way table. When reading a two-way table, you can consider many different sets of information. Every column, every row, and every intersection of columns and rows can state a different conclusion about this data set. So let's look at our chart that we just looked at earlier. So if you look at every row, it's going to tell you something different. So this row is all about the people who like snowmobiles. This row is all about the people who do not like snowmobiles. This column is about the people who like skateboards, and this column is about the people who do not like skateboards. Every intersection will tell you something different. So for example, the 80 is going to tell you that 80 people like skateboards and like snowmobiles. The 25 tells us that there are 25 who do not like skateboards but do like snowmobiles. The 45 tells us that there are 45 people who like skateboards but do not like snowmobiles. The 10 tells us that there are 10 people who do not like skateboards and do not like snowmobiles. The outside row and column tell us the totals. So this is the total amount of people that said they like skateboards. This is the total amount of people who said they liked skateboards, do not like skateboards. Together, 125 and 35 make up the total amount of people surveyed, which was 160. 105 represents the total amount of people who like snowmobiles, and 55 represents the total amount of people who did not like snowmobiles. So you can see that every one of these intersections means something different. That's how you read a two-way table. Now our second skill is going to be to finish a partially completed table. And what you do is you use addition or subtraction to figure out what you don't know. So we'll start here. We know that there are 187 people in all that responded to their after-school activities, and that it has been sorted by boys and girls. Well, if there were 187 people overall, and 102 of them said yes, how could we figure out how many said no? Well, we would subtract the two. 187 take away 102, and you get 85. So there were 85 people altogether that said that they do not do after-school activities. Now let's build off of this. If there's 85 people who said no, and 40 of them were boys, how many of them were girls? Take 85, take away 40, and that leaves us with 45 girls who said they do not do after-school activities. Now let's build from here. 95 girls were asked in all. 45 of them said no. 95 take away 45 is 50. So that means that 50 girls said yes. Now let's build from here. If there were 102 who said yes overall, and 50 of them were girls, how many of them were boys? We'll take 102, take away 50, and you get 52. That means that 52 boys said that they do after-school activities. Now we can add this row to figure out how many boys were questioned altogether. So if 52 boys said yes and 40 boys said no, if you add those together, 52 plus 40 makes 92. So there were 92 boys altogether surveyed in this situation. And if you add 92 and 95, you can see you get back to the total, which means that this makes sense. Our last skill is to be able to calculate percentages based on a two-way table. When you're calculating your percentages, always start with a fraction. So here's our example. What percent of people responded that they do not like skateboards and do not like snowmobiles? So we're talking about the people who do not like both. So come down the column, they do not like skateboards, they do not like snowmobiles, so that's 10 people. Now the other consideration you need to make is who are you talking about? We were talking about the percent of people. That would be everybody. So that's 10 out of 160 said they do not like either one of those. And if we take 10 divided by 160, we get 0.062. The 2 is used around the 6, which keeps it the same, so we get 0.06, which is 6%. And then I would restate my answer. 6% of people said they don't like skateboards, nor do they like snowmobiles. Let's do one more percent example. What percent of people who like skateboards? Now look, we're not looking at all people. We're only looking at the people who like skateboards. So that means that I'm only using this column of the data. So of the people who like skateboards, how many do not like snowmobiles? Well, there are 45 that do not like snowmobiles out of 125. Again, divide that to make it to a percent. 45 divide 125, we get 0.36, which is 36%. And then you could restate your answer. 36% of the people who like skateboards do not like snowmobiles. So let's summarize what we've learned. A two-way table organizes two sets of categorical data. It can sometimes be numeric like numbers, but uses rows and columns either way. When reading a two-way table, every column, every row, and every intersection of columns and rows can state a different conclusion about the data set.